a little bit of a shitpost on intents. I'll also give like what I think are the good parts about intents, and then eventually I'll get into like how you can use Suave as like intent infrastructure. That's like the rough arc. The theme is largely inspired by this meme I made. If you're familiar with this format of like stop doing X, Y, Z, you know, the main points. Yeah, years of meta transactions, we have nothing but limit orders. That's like the sort of like the edge of intents right now. Yeah, what else is here? Yeah, that's about it. Oh yeah, and then hello, I'd like an intent to not be front run. I think that's like also a little bit of a spoiler for the rest of the talk, is that like front running is still very possible with intents. It doesn't totally solve that. It can move it in a meaningful direction, but yeah. Cool. Yeah, so this is the rough arc. Intents are a PSYOP. Intents are probably the right abstraction. Audit your intents. And then yeah, Suave as intent infrastructure. Cool. So yeah, the bear case, like this is why I would say, this is how I would say like, you know, intents like aren't really that crazy or anything like substantially new. There's been like 30 years of like, you know, UX research in Web 2, and like we're suddenly bringing that now to like Web 3 with intents is sort of my argument. Yeah, so EIP 712 meta transactions, those have been around for a while. You know, if you've ever used OpenSea, those use meta transactions under the hood. And those don't really specify a specific like execution path. So, you know, you sort of just say, oh, I have an NFT and like I want like around this much, and like that's sort of what you get. Yeah, so yeah, giving users like, users giving more optionality to their executors, like I think, yeah, that'd be the other part of the bear case is like, is that really where the bottleneck is right now? Like, you know, are all of our like UX issues in Web3 suddenly solved if like, we're like, oh, now a searcher has way more options for how to execute my stuff? Like, no, probably not. A lot of it is like users are confused, wallets, like cross-chain interaction, things like that. Yeah. And then, yeah, CowSwap is also already live. That's an intent platform as well. You don't really specify your execution path. You sort of just get thrown into like a batch auction with a bunch of other people, and then your like intent is satisfied or your desire. Yeah, and then lastly, for the bear case would be like it still reduces down to a market structure issue, and so the intent language can have an effect on the market structure. Like if your intent, you know, obstructs a certain party from being able to solve your intent, then like, yeah, that could potentially cut off parts of the market that you maybe do want, or maybe your intent structure could incentivize other market participants to like come in and solve it. Yeah, so that's like the bear case, and then I'll just quickly go through like what I see as like intents, the progression of them. So this is sort of like abstract. I wouldn't like look into this too much, but this is how I think about it. Like I have some token A and I like want B. I tried to do this on like an X and Y graph, but it ended up looking too much like an AMM, and I didn't want to confuse. So yeah, like this is like uni V2 or maybe V1, like no router. Like you have like one exact path. Like I need to go through this pool, and I can only like satisfy X times Y equals K for that single pool. And then, yeah, okay, maybe this is like V2 plus the router is like the router gives you like multiple different paths you can go to now. And that's like a huge improvement, because now you can maybe go through like multiple pools that you didn't specify. Yeah, and then I would say this is like more what intents look like. You just specify this entire space as like a set of constraints. And anyone can satisfy those constraints. And so that's like a single person intent, right, for a single token. But a lot of like intent infrastructure or intent like solver networks, like what they do is they take this and then they combine it with like a bunch of other people's intents, right, all like in this like one little box. So yeah, I think like the intent infrastructure starter pack, it's like an ability to aggregate all of these sets of constraints into like one cohesive unit. And then, yeah, you sprinkle in some like crypto, like DKG, like perhaps you encrypt your, you know, set of constraints to, I don't know, like some like public key that the network like creates and rotates around. I think people, I think like Fervio is an example of this like DKG infrastructure on, I think, Osmosis. It's live right now. Yeah, and then decentralization of compute and storage. Like, we don't really get anywhere if you just encrypt, you know, your intent constraint into like my phone. Like, that's not really the goal here. Like, we want a like marketplace of solvers competing for different execution on different constraints. Yeah, so that's like what I would view as like, yeah, the bare necessity, and how you actually like encode these constraints into a way that a user can like specify, I think is where all of the intent work is. So if anyone's working on intents, like, you know, would love to talk about that. But yeah, again, like the language you specify to your user is gonna like determine the constraints that they create. I think there's like a really big argument as well that users don't know what they want. So like a really good example, I think, is like Google Flights. If anyone's like used that, I use that to like book here. Like, I sort of say where I want to end up in a date, and you could imagine that as constraints. And then it sort of comes to a bunch of solutions for me. What's interesting is like the Google like search, the Google Flight Search, like what they'll do is like they'll actually show you the cheapest, and then after that, I believe they show you like, or sorry, they show you they show you the cheapest first, and then after that, they show you the shortest flight and the cheapest, and then I think they have like some other like priority ranking for like what they show you. So I think there's a lot of room for platforms to like make sort of like to choose these preferences for the users, because I don't really want to think about what my ordering of preferences are. Like, typically that like 99% of the cases, the cheapest one is like what I want to go with, and then maybe it's 20 hours versus 10, like, all right, cool, I'll go to the second one. So yeah, so that's a good example. Like, I think and this goes back to the bear case of like too much, like if, you know, say I expose 100 parameters to a user, that really like doesn't solve any of crypto's like UX issues. Cool. Yeah, so the bull case. Yeah, so it expands the discourse to include a user's behavior and motivation. That's sort of what I was talking about before. Cross-domain intents are also something that's like really interesting that you can expose. If, you know, a user simply specifies these end states, then if I can satisfy, if I can like provide some type of proof that I did the required action on one chain and then like bridged it back, then like that's super fair game. And so that's like really awesome that we can sort of use this abstraction to move to a world where like the actual chain you're on doesn't matter as much. Yeah, other builder superpowers, and so I sort of refer to this like cross-domain ability as like a builder superpower. That's like a very ETH-centric thing. If you're not in ETH, like on the ETH world, sorry about that. But yeah, you could do things like multi-transaction flash loans is like one builder superpower you could enable. So like right now, you know, if you do a flash loan, you have to return the liquidity by like the end of your transaction execution. But if you're the builder and you're in like control of the entire block, and you're even in control of another block on another chain, like you can do like very interesting things. You can maybe even mix in signals from like domains that aren't even on a chain. It's a little unclear like how you verify and then like show that information to a user, but like all awesome possibilities. Yeah, and then this is the strongest one for me. It's way more marketable than invariance. Like, I think a lot of intents are really just invariance. I think even like slippage is sort of an invariant. Like, I think we do have some basic, you know, things like this right now. But yeah, no one wants to say like my invariants are XYZ, but like, oh, my intent is to get a token. Way more marketable. Cool, yeah, so that's like roughly, yeah, those are my bear and bull cases for intents. I think it's like unclear where intents will go, like whether these will actually be some type of like, you know, someone will design some like domain specific language that like everyone uses, or maybe like certain actions will have like intents that become like very standardized, and then you could use them across like every single like application, or like a couple of them. If you imagine like your phone, like you probably have like hundreds of apps, and so like, do we imagine each one of those is going to have their own like domain specific language for getting things in and out that you want? Like, no, like probably a lot of apps you transact, and so like a very basic pattern is like, you know, what you're giving and what you want. I think this is like the ANOMA intent, like language and structure is like based off of this. So, you know, you're on Instagram or like TikTok or something and you want to buy, you know, something, you could, you know, you specify how much you're willing to put in, and then you specify how much you're willing to get out, and yeah, it really doesn't matter. And so that's what segues into my next point, which is, you know, you specify how much you're willing to pay in basic versions of intents. But like if these intents are public, then we're actually just in the same exact place we are with the transaction supply chain and MEV. Because if I'm willing to pay 100 for, you know, 100 USDC for one coin, you know, no one's gonna be like, oh, let me just give you like 90 for one coin actually. Like, no, we're gonna, you know, searchers, executors, whatever you call them, solvers, are gonna push you like right up to the limits that you express. And so this reduces back to like the MEV supply chain, is my opinion. So yeah, and this is sort of where I get eventually back, like go more into Suave and like less on intents. So yeah, the state of MEV, this is like a rough transaction supply chain, intent supply chain now, it's new. Yeah, so yeah, when users transact, they generate more value sometimes than they generate value that's like, you know, internal or external to the system that they don't even realize. You know, being able to combine multiple different orders can maybe move a price in a different direction that you didn't expect. Yeah, so right now, this value is mostly captured by searchers and validators. Originally, the network sort of captured it in a sense with priority gas wars, but then Flashbots, we introduced, you know, a way for you to like privately express these preferences. And then now with like PBS, proposer builder separation, like sort of the design philosophy that like validators and, you know, maintainers of the network's consensus like shouldn't be the ones responsible for building blocks. With PBS, like I think it's like 90% of the value now ends up with validators, and that's because of the market structure where the PBS design is basically a first price auction. So it just incentivizes everyone to sort of bid max until they win the auction. Yeah, and then users can be negatively impacted by some strategies. That's like front running. And as I mentioned before, like intents, you can still get sandwiched with an intent depending on how you structure it. Yeah, so that's the state of MEV. So yeah, we protected with these private channels, we like protect the chain from negative externalities. We don't have priority gas wars, but we don't internalize any of the value. And that's like the really interesting thing. Like, yeah, it's actually really similar. If you think about like restaurant reservations, I think that's another example of like somewhere that actually could maybe potentially internalize this demand, where like, let's say a restaurant only has like 10 reservations in a day, and like all of them, you know, get booked for free, or maybe there's some like minimum cost you have to like stake, which is like Sybil resistance in a way. Like you could actually have like secondary market like trading on that, and like none of that value goes to the restaurant, even though it's like their actual spots that are like generating this contention for usage. Yeah, so that's a big issue. Don't internalize value. Yeah, so we have private channels. That's like the main approach. There are smart contract approaches, which are really interesting, and I think intents will allow more expression into how smart contracts can internalize this value. Yeah, some quick examples are like liquidations in the maker auction, or the maker liquidations maker chose like a Dutch auction to sort of remove some of this like the negative externalities of everyone just like, you know, sending in tons of bids. Now it's with the Dutch auction, it's just like, oh, that's the price I want, I'm taking it, like auction over. Depending on if you can get on the chain, which Max had a lot about. Yeah, NFTs, gradual Dutch auctions, that's like another approach. Art Gobblers used it. Yeah, and then AMMs, like order flow discrimination, has like mixed effects. If Alex ends here. Yeah, like that seems to be like one approach as well to internalize some of this demand. Yeah, so those are current solutions, but like they're not really good enough is what our view is. So we introduced and have been working on like Suave, which is a system to like handle all of these things. And so at a very high level, this is like the different users of Suave and like how they would specifically interact with it. But you can think of it as like, I'll start with like a concrete example. So like MEV blocker or MEV share, if you guys are familiar, it's sort of like you can submit a transaction, and then so with MEV share, we will like release a subset of the information that searchers can then search on and send a transaction back in, which will backrun it. MEV blocker does something similar, except they just like reveal the full information, and then they in order to stop like probabilistic sandwiching, they introduce like fake transactions. It's yeah, that's their approach. So with Suave, like what you can actually do is you can encode that logic for your like order flow auction as a smart contract. You can then deploy it onto Suave, and then the key here is that the user will then encrypt their transaction to the like Suave network, and then they'll send it into a Suave node. And then what happens is anyone can now run the auction, and so you have like a verified program that they're running on top of like confidential bids. And so the other cool thing that like smart contract enabled OFAs give you is that you can actually control the privacy model. So like if you want to leak some of the information as in MEV share, like you can actually choose to do that. And the user specifically allows certain contracts that they send their bids to. So if I can write some contract that will just like leak all of your information and like give you nothing. And as the user, like you're free to click on that and use it. But we think like also, you can also submit to like some really shitty like AMM as well. And like, people don't do that right now because they sort of, there's various like network of trust types of scenarios, people verifying, like, yeah. Yeah, so that's basically it. And then we also envision like people, like searchers, builders, etc., like running a lot of these nodes, and so they're incentivized to try and like get as much order flow. Another like cool thing that this solves in the builder markets that I had personally experienced working on another builder is a lot of the iteration on block building mechanisms is like most heavily constrained based on the order flow that you have. Like if you only have 50% of the order flow and say you want to like compete with like, bundle merging with like, Jared from Subway or something, the infamous sandwicher, you can't really like meaningfully iterate there if you don't have their flow. And so this stops a lot of builders from like being able to iterate. And so we hope that like in the base case, Suave will allow lower the barriers to entry of the markets to be a block builder, because you can sort of like, based on some tenuous trust constraints in the beginning, you can get access to the entire order flow of everyone submitting through Suave. Cool. So these are the takeaways, if none of that made sense. Replace trust and operators with TEs, maybe eventually like threshold MPCs, some type of cryptography. I think like if we had the exact same block building infrastructure as we have today, but it's on TEs, like I think we're in a radically better place. Like this isn't the 5 to 10 year like timeline of like what this like market will actually look like, but we think it's way better than you just trusting some random server that like says they won't leak your data or something like that. And then many people have opinions on TEs. We have a lot of approaches and very experienced like SGX engineers on like how to mitigate exploits and things of that nature. I think the quick answer is like, if there is an exploit and like 3 blocks are like unbundled, that's like really bad, yes. But typically, that's like, it's not as bad as Ethereum going down. And on top of that, like sort of a lot of the people finding these exploits are like very sophisticated labs, like doing it for academic clout. They're not necessarily like some 16-year-old like in their bedroom, which it could, that would also be cool. Make the operation of the service decentralized geographically and administratively. Like ideally one person shouldn't be able to shut down the system. And then geographic decentralization is like a much harder concern, and that's a little bit longer term. And then user programmable based on smart contracts. The real vision is like a marketplace for mechanism. Like any degen sort of AMM designer or smart contract dev should be able to just like read a tutorial, deploy their own OFA on top of like Uniswap, and like you could actually like meaningfully compete with Flow, and you don't need to be like associated with Uniswap or anyone. And then, okay, these next few slides are a little technical. If anyone's like familiar with like how an Ethereum node works, like you have like the EVM, you have like the state DB is like the main place you store things, and then like some configs and contexts. And then here's like, so over here is like all traditional EVM. And so, yeah, you have this like runtime, which ends up like at the interpreter, which is like what, translates your bytecode and actually runs the execution. All that the MEVM is it's a new runtime. We call it like the Suave OffChain Backend, and it just like plugs right into the interpreter. And so now at execution time, your code has access to these fields, one of which is misspelled. And so, yeah, you get a confidential backend that your execution gets access to. And then as well, this like off-chain ETH backend. So you can sort of like call functionality that's used in traditional block building, such as like simulate a bundle or build a block. You get access to all of those inside of your smart contract, which is really awesome. So you can deploy a program that will take in a transaction, simulate it, do something with it based on the results of the simulation, maybe like route it to another smart contract, and you can kind of like stack these things. So you could imagine like multiple layers of OFA contracts, and then maybe multiple layers of like block building contracts, and then multiple layers of relay contracts, and they all can sort of like plug and play. And the point is like not to be prescriptive about like what the right route through the supply chain is. It's, again, allow anyone to propose new ways that these like mechanisms can interact and operate, and then just like let the market win for which one's the best. Yeah, so what are the differences like in terms of UX on like using Suave? So this is like the transaction supply chain before. You go from like user looking at the UX to a wallet, they send it to an RPC. That RPC will somehow end up at a block builder. If it's an OFA, then it'll forward it. Sometimes it's like, you could view like Infura right here, who sends it to a mempool, and that's like, the public broadcast to all the block builders. And then, yeah, block builder sends to relay, and the relay sends the proposer. That's sort of like the PBS part. So yeah, the main differences here, yeah, so Suave does not make any types of like opinionated claims about this portion. Like that is for anyone to sort of go out and design like an intent framework that can operate here. And then, yeah, so what are the differences from there? We have a new transaction type called an off-chain transaction type. It basically is like a regular Ethereum transaction, except the call data is for a function call on Suave, and then there's an additional field called confidential input, which is like your encrypted bundle. But other than that, exactly the same, like one or two field differences. As well, you also specify which contracts are allowed to execute over your transaction. Yeah, so the RPC is also slightly modified. Send raw transaction just takes this new off-chain transaction type. How the RPC and the block builder communicate, that is also different now. They communicate through the confidential data store. So your OFA can output a combination of the user's bundle with like whatever transaction the OFA might have inserted. So in MEV share, that's like a refund transaction. And the way they communicate that is just by passing it again through Suave internally. And then, yeah, as well, block building, the way it communicates with the relay is through this confidential data store as well. And typically these two have been like HTTP, like you just like do a post request. So we think that's cool. And then, yeah, this portion will probably stay the same for a while, the relay to proposer. No proposers are like native to Suave, so that's like, will definitely always be the last mile. We hope that there will be like some cool peer-to-peer network standards that'll come out so that we could just like broadcast these commitments to proposers and then they could accept, but that's probably a long way to go. Yeah, so there's intent infrastructure on just like many different domains being worked on. Yeah, PBS, like you can view as sort of like the last mile intent delivery. If the guarantees we have with PBS aren't satisfied, if a builder's block is able to be like unbundled, is an attack we saw like in Ethereum where a malicious proposer basically said they were going to propose a block that came out of the MEV boost auction, but then they didn't. And then once they received the block, they took out all the transactions, just sandwiched everyone, made like 20 mil, and then just like left. And they, of course, got a slash on the Ethereum network because that's an equivocation. But I think they made like, a couple mil, and the slashing penalty is like 20,000 or something. So it was nowhere comparable or incentive compatible. 4337 is also approaching probably the earlier part, is like maybe intent propagation. And then OFAs as well. No OFA, all OFAs right now take transactions, just like regular transactions. I think if someone just made a partial transaction, like OFA, similar as MEV share, like literally just fork MEV share, like I think that would be a super cool thing that people might use. Cool, so last, like what's possible with Suave Geth? So you can build an OFA in Solidity deployed on Suave. You can build a builder. DEX aggregators, you could also build them there. DEX aggregators are like really awesome today, and I think like if you want the best deal, like you probably go to 1inch, or like CowSwap as well. So you can do all of that same logic except just on Suave, where you know the computation is like guaranteed to be like what you allowed, and then as well you know that your data is like private up into the amount that you specified. Same exact experience, maybe a little bit slower in the beginning because of some of the additional stuff we have, but like in the limit, these things will be like very comparable latency-wise. RFQs, sort of similar thing, and that might even be a repeat of DEX aggregators in some way. Validity conditions, you can specify like very arbitrary conditions that your transaction's allowed to be included on chain. So like one example is a refund. Like I am only going to allow my transaction on chain if I am sent half of the MEV extracted back. So you can encode that in a smart contract, and it just won't even give your bundle to a builder unless that condition is satisfied. Redistribution, same thing. So intents and quotes, like anyone could build, like if you create one of these like, languages to express intents, then you can easily create an auction for it on Suave as well. Proposer builder commitments, you could imagine like much more advanced commitments than what we have now. I think the talk after this probably is going to touch on that. You could do private voting, like that's not really a use case we're sort of like focused on, but you have privacy and you have very cheap computations, so you could in theory. And then this is the last fun one as well, if anyone wants to work on this, 4844 blob merging. Right now, the way 4844 is structured, you pay like an upfront amount, even if you don't use the entire blob gas. So people are talking about, so you can imagine rollups like that only need like a third of the blob gas in a specific transaction. And then because of the, properties of the underlying cryptography, you can actually combine these transactions into one, and it'll still satisfy everyone's like original intent. So you could design something on Suave which would like merge these. I don't know if you need privacy for that case, but you would get the decentralized aspect of like running that service. Cool.
Any questions?
Yeah, I'm wondering, have you done any research or have any thoughts on state drift and its effect on, say, solvers and builders that are doing something intent, for example, on a chain that has faster block times, at like 12 seconds, where state changes a lot quicker?
And what was it? You said state drift, or?
Yeah, state drift. So obviously, on Ethereum, state will change out every 12 seconds.
Right.
Let's say you're supporting something that's 0.5 seconds block times.
Oh, you have a comment?
Yeah. I think there's I'm not sure if Diego is going to talk about it, but there's an interesting use case around like using the Pepsi as external commitments to cater for situations like state drift, where you have a fast chains like Suave that's running like bundling blocks at a lot faster rate than like 12 seconds. But then how are you going to get commitments for that things that you just bundled that's like finished like maybe like a few seconds ago? Well, that way like to get that commitments, they can use like something like Pepsi to say, okay, I'm going to use Pepsi to commit to this, like let's say something that's created from Suave, such that even though it's like many seconds delayed, that later on can still get published to the blockchain, for example.
Yeah, and to add to that further, I think one of the things I'm working on personally, I'm calling it like Suave subnets right now, but so yeah, no more terms. The idea is like, okay, so we have like programmable privacy, but the Suave chain is like much faster, but like if it's 1 to 3 seconds, that's like still not fast enough for some applications, like traditional finance is whatever in the nanoseconds, so that's like where we need to end up in the like 10-year timeline maybe. Yeah, so one thing I'm playing around with is like whether a smart contract could actually like specify the DA guarantees that it provides. So you could do something like, you know, have only a subset of nodes run like the UniX auction perhaps, and they could do, you know, that OFA, like however it's designed, could maybe specify like, you know, like 200 millisecond like rounds. And so those nodes have to come to agreement on like which transactions are available to all of them. And that can be like used as input to the auction. That's like one idea, but it's certainly like an open question. And it gets into the idea that like, you know, if the main Suave chain is like this like global bulletin board, you know, one application doesn't really care about whether or not another application's like data is available. Like if you're the block builder, it does, but if you're like CowSwap, it doesn't really matter what like Uniswap is doing. So yeah, we're playing around with that.
Subnets.
Yes.
Actually, just a quick question for like some I guess something I noticed. So you mentioned about the multi-block multi-transaction flash loan, or the block flash loan, as part of like the possible intent use cases. I was thinking like specifically for that, like how are you like trying to integrate like intent aspect to that multi-transaction flash loan?
Oh, we're not really like working on that. It's just sort of just like an idea. Yeah.
Okay.
Yes. Yeah. But yeah, I mean, it is funny because I think like if you combine multiple intents into one transaction, you might not even need a multi-transaction flash loan because it's like technically one. But
Right.
yeah. Yeah.
You mentioned wanting to use SGX. Have you thought about using like ORAM or something?
Oh yeah, totally. Yes, we're looking at that. ORAM is just like really slow. I mean, as all these solutions are. We have some people working on it though. We've seen some. I think we saw like a 30% improvement in benchmarks with a recent paper that came out from a Flashbots researcher. So we do think that's like a very interesting use case. Yeah.